This week is packed with Starship news, an ambitious launch cadence projection which is needed to launch SpaceX's massive AI satellite constellation, a rather interesting but perhaps underwhelming update about Starship's involvement in the Artemis program, a short-term projection for Starship's upcoming flights that will keep us paying close attention to vehicle production, testing and Launchpad progress for months to come, and much more is in this Starship update. First, let's talk about the news, starting with the talk that SpaceX uploaded on Monday, going over some of the plans with their AI satellite mega constellation. Before you tune out, this is relevant because these satellites are being designed to be launched on Starship. In the talk, SpaceX presented their first version of an AI satellite called AI-1. The satellite design builds off the experience and design of the Starlink V3 satellites, fitted with big solar panels and big perpendicular radiators to maximize electrical throughput and thermal radiation. According to the talk, these will start launching in late 2027, with mass deployment occurring in 2028 and the following years. Remember that SpaceX's plan is to eventually launch 1 million of these AI data center satellites into orbit, but this most likely will be done over multiple versions of the satellite, similar to Starlink. Another big bit of news came out the following day on Tuesday, with NASA holding an event to provide an update on the Artemis III mission and announcing the crew. This mission will feature an Orion spacecraft meeting with a Blue Moon lander from Blue Origin and a Starship from SpaceX. The Blue Moon lander will carry a functional cabin, and the crew of Orion will go inside and test the new lunar spacesuits made by Axiom. However, this Blue Moon lander would also be missing its main propulsion systems and just carry attitude control thrusters. Starship, on the other hand, won't carry a crew cabin, but will rather just be a standard ship taken from the production line fitted with a docking adapter. This decision is a bit weird because we had all assumed that both landers flying on Artemis III would be as close to the final product as possible, given that the intention was to buy down risk ahead of the Artemis IV landing. In addition, it was officially announced that SpaceX and NASA are looking into using Starship on later missions to perform Orion's trans-lunar injection burn, as well as the lunar orbit insertion burn. So, in this scenario, both spacecraft would need to meet in Earth orbit first before going to the Moon, rather than docking first in lunar orbit, something that would be safer for the crew as they could return home within a day, and it would also save Starship several propellant aggregation flights as well. But you'd already know that if you were subscribed and watch our weekly news show This Week in Spaceflight, which we release every Friday. The last major piece of news came on Friday, the day that SpaceX went public on the stock market. As we've mentioned before, we're not here to talk about financials or investments. We don't do that sort of thing. We like space. The thing we're interested in is an interview and tour of Starbase's facilities with Gwynne Shotwell, SpaceX's President and Chief Operating Officer, released by CNBC. During the interview, she explained the short-term plan. Starship Flight 13 is potentially happening next month, with monthly flights after that. Flight 13 would be another suborbital flight to fix and perfect the issues from version 3's debut on Flight 12. If that goes well, then Flight 14 could be an orbital flight, and Flight 15 would then be the first Starship launch from Florida. So how's the progress on those vehicles for July's Starship Flight 13? Well, this week, Booster 20 completed its cryo-proof test campaign and returned back to Mega Bay 1. Presumably, this test campaign went well. With the booster in the bay, teams will further perform vehicle outfitting and its engines will be installed. With the previous booster, B-19, we saw SpaceX conducting 2 engine test campaigns, one with just 10 engines and another with all 33. It's very likely that this was just a one-off, considering it was the debut of version 3, and that for Booster 20 we'll see all 33 engines installed right away. For Booster 19, the time between the end of the cryoproof campaign and its first rollout to Pad 2 was exactly 1 month, but as I just said, that first campaign was with only 10 engines. We had to wait another 3 weeks until it rolled out again for the 33 engine test campaign. So with Booster 20, it may very well be another month or so to fully install all engines, conduct further outfitting, and prepare the booster for engine testing. In that case, this would lead to its engine test campaign being around early to mid-July. In the case of Booster 19's timelines, it then took another 3 weeks to a month from the end of its 33 engine test campaign to the final engine testing and full stack launch campaign. Assuming these timelines could also be shortened thanks to the lessons learned from Flight 12, then a launch at least at the end of July might be possible, but don't be surprised if it moves to August, especially if they encounter issues either with the vehicle or the pad hardware. Ship 40, Booster 20's companion for Flight 13, also needs to be ready, but it's further along than Super Heavy. It already completed its cryo-proof test campaign about a month ago, even before Flight 12 happened, so we're still eagerly awaiting this ship to leave Mega Bay 2 and head to Massey's for its own engine test campaign. After that, it'll undergo final outfitting, checkouts and preparations for flight, and will be rolled out to the pad once the booster and launch pad are ready to go. So from a vehicle perspective, and if all goes well, Flight 13 could realistically happen in July. On the Launchpad side of things, it's all a bit more unknown. Teams are currently working across multiple parts of Starbase's Pad 2, not only performing inspections and repair work following Flight 12, but also what seems to be upgrade work that might have been planned prior to that flight. For example, last week we mentioned the replacement of the chopstick landing rails for a new lightweight version. Between episodes, teams have also been removing the skates from the chopstick carriage system. The carriage is the system that supports the chopstick arms and hugs the tower, letting it roll up and down the structure, with the help of guide rails on the tower columns. The skates have wheels on them that roll over these rails, and this helps the carriage move as the drawworks pull or release the cable. These skates aren't really simple pieces of hardware, so there's a good chance these might be long lead items and that this work had been planned well before Flight 12 happened. That doesn't mean that there aren't things to fix though. We've seen teams working down in the flame trench and also rebuilding the pad perimeter wall that was destroyed at launch. Scaffolding has also gone up at the wall where the Gateway to Mars sign used to be. SpaceX might be thinking of different ways on how to mount a sign there. Third time's the charm? Earlier I said we're now waiting on Booster 20 and Ship 40 to undergo their engine test campaign, and that'll mean 39 Raptor 3 engines will be tested while attached to a vehicle. That also means the next batch of 39 engines needs to be tested and readied before they are mounted onto the next pair of vehicles. That readiness and testing should be underway at SpaceX's McGregor test facility in Texas. In the past week, we've seen 12 Raptor tests at the site, with 9 of them taking place from the original Raptor vertical stand. All 9 of these tests were about the same burn time at 104 or 105 seconds in duration. These regular tests at fixed durations are quite possibly acceptance tests of the engines in order to clear them for installation and flight on future vehicles. Along with those tests, and as has become usual, we've observed a number of Raptor engines passing by our McGregor live cameras available 24/7 here on YouTube. Also, shout out to the drivers waving at our cameras as they pass by. Among these engines was a new record serial number, SN178. We also saw a few other similarly numbered engines such as 173, 174 and 177. We also spotted an old Raptor 3, and yes, believe it or not, there are now old Raptor 3 engines which had its turbo machinery missing. Safe to say, SpaceX has a really good stock of engines, and testing continues at a normal rate compared to what we've seen in previous weeks. So if, according to Shotwell, Flight 13 is next month and they're targeting monthly flights right after that, Flight 14 is sometime in August. To happen, that means the next pair of vehicles, Booster 21 and Ship 41, obviously have to be ready for flight by then. Ship 41 completed stacking about 3 weeks ago and has been sitting on the central workstation inside Mega Bay 2 ever since. Over the last few weeks, teams should have performed outfitting of the vehicle with its pressure and data lines, as well as sensors and other key pieces of hardware. We also saw them installing the aft flaps and finishing up the thermal protection system over the last weld lines between barrel sections. In fact, our field team spotted crews trimming the crunch wrap that's used to fill the gaps in between the heat shield tiles. It's named as such because the felt material is wrapped around the back side of the tile and sticks out from the sides, filling the gaps in between each tile. Then, once the tile is installed, they trim the excess material, as we can see here. As part of the pre-launch test campaign, Ship 41 will follow in the footsteps of its elder siblings, first going to Massey's for its cryo-proof campaign. Then it should return to be fitted with Raptor engines and once again roll out for static fire testing at Massey's, the same process we explained earlier for Ship 40. Given the timelines, it seems like Ship 41 may be ready for a launch sometime in August, aligning with Gwynne time, provided that a cryo-proof test occurs this month and that it carries out its engine test campaign next month. As for Booster 21, its timeline might need a bit of a crunch. This vehicle is not fully stacked yet, it's much further behind than Ship 41. This week we were able to see its liquid oxygen tank exiting Mega Bay 1 as it left room for Booster 20's return to the bay after its own cryoproof testing. Booster 21's liquid oxygen tank then rolled back into the bay and stacked on its aft section not long after that. The vehicle is still missing its methane tank, which means there's still more stacking left for this booster. And even after stacking is complete, there's still outfitting of pressure lines, raceways, installation of composite overwrap pressure vessels or COPVs, and also the installation of the chines to protect said COPVs. So in order to meet schedules, SpaceX will have to shorten the timeline with Booster 21 to about half of what we've seen with Boosters 18 through 20. Then there's the added twist of Flight 15 possibly launching from Florida. This milestone will likely hinge on not just vehicle production, but also the success of the previous flights. As you might have guessed by the previous check of vehicle timelines, the ships seem to be further ahead in their construction and testing than the boosters. Now, if only they could just catch and reuse a booster, this disparity in timelines would effectively reset, and SpaceX would have a booster ready to go before the next ship is ready. In other words, SpaceX really needs to start catching and reusing boosters in order to meet their ambitious goals, even in the immediate future. As Shotwell mentioned to CNBC, Flight 13 will largely be a repeat of Flight 12, fixing the few things that went wrong, such as the booster's return. That could hopefully lead to a booster catch on Flight 14, which, if successful, would essentially leave them with an extra booster to spare that could then be used on the following launch. Flight 14 could also be the first orbital attempt for Starship, but the way Shotwell explained it seemed to imply that it wouldn't get to orbit right away.
I hope on Flight 14 we'll follow basically the same flight, with the exception if we feel like we can actually go to orbit, then we would actually have that gate and have the FAA let us go to orbit on Flight 14.
Instead, she alluded to the FAA letting them go into orbit and also using a similar profile to Flight 13. That seems to be a contradictory statement, but to explain what she might have meant, SpaceX may still do an initial insertion burn with the ship targeting a suborbital trajectory. The main difference is that they can still then check if the vehicle is in good shape and whether it's healthy enough to be kept in orbit. If it is, a relight could be performed during the coast phase that fully circularizes the orbit and inserts Starship into a proper orbital trajectory. If for some reason they find that the ship is not healthy, or the team's confidence with the vehicle is not very high, then it would still continue on its suborbital trajectory and re-enter over the Indian Ocean. This is similar to how on Flight 12, due to the engine out during ascent and the overall engine health data from the ship, SpaceX teams decided not to go ahead with the planned in-space relight test. In this hypothetical scenario, it would leave SpaceX in a rather interesting position. They would have sent a ship to orbit and proven they can do an operational mission, and caught a flight-proven booster that they could refly on Flight 15. Should that mission also be the first from Florida, it also makes the case for a Booster 21 reflight much stronger, because instead of stealing a brand new booster and leaving Starbase without a Super Heavy, they would just take one that's already been built, and flown too. Flight 15 would then only require a brand new ship, Ship 42. This past week, we saw its nose cone had already been stacked onto the payload bay inside the Star Factory. It may stay there for a few more weeks, but it won't be long until its Pez dispenser is transported into Mega Bay 2 and major stacking begins inside. In that case, and if it follows a similar timeline to Ship 41, Ship 42 could then finish stacking about a month later. If the stars align for SpaceX, they might, and big emphasis on the word might, then be able to carry out a launch at the beginning of the autumn. But it's not just the booster and ship that need to be ready for that, but also the rest of the infrastructure needed for the daunting task of launching Starship for the first time from the Sunshine State. Just this week, we saw the arrival of the transport barge Marmac 31, also known as You'll Thank Me Later, with the delivery of 3 Starship transport stands to the Kennedy Space Center. 2 of these stands are for ships, and the 3rd is for boosters. Following their unloading, all 3 were transported in the direction of Launch Complex 39A, rather than going out to SpaceX's Roberts Road complex. It wouldn't be surprising if SpaceX ends up testing the transport stand connections with the Launchpad systems, just like we saw in the months leading up to Flight 12 at Starbase. Even to a quick glance from the untrained eye, LC-39A is still not ready, but how much work is left? Well, it's not as easy to see the progress here compared to Starbase given the restricted access, but what we can see via ground and overhead views is that there's still a lot of work to come with the launch tower, launch mount, chopsticks, and quick disconnect arm. We're yet to see a full test of the pad's deluge system, and there's still hardware clearly missing from the launch mount that should be installed before even thinking about testing. Could 39A be finished in 3 to 4 months? If SpaceX can speed things up, they might be able to get at least an operational pad, even if not fully outfitted. There are areas such as the tank farm that may not need a full set of pumps, subcoolers and/or storage tanks in order to get away with a launch. Maybe, considering their prior experience, they can also get away with fewer tests of the ground systems in the lead up to launch, which made up for a lot of the work we saw at Pad 2 in the 6 months or so leading up to Flight 12. All things considered, it's really hard to tell whether a launch can happen that soon. But what do you think? Do you think these timelines are credible, or is Gwynne time merging with Elon time? Let us know what you think in the comments. Now let's look a bit further into the future with the Artemis news, since those flights should follow not long afterwards. At Tuesday's press conference, SpaceX's Vice President of Customer Operations and Integration, Jessica Jensen, announced that the company is still planning a ship-to-ship propellant transfer demonstration later this year, so presumably this would happen not long after Flight 15 takes place. That makes sense because by that point, SpaceX should already have LC-39A operational, giving them a couple of pads able to launch Starship. At some point, ship reuse will also become a thing, which should help drive up that cadence that is dearly needed for Artemis, and for all the other projects like Starlink and the AI constellation. We'll talk about that later. As mentioned earlier, the news that Starship won't feature a crew cabin of any kind really stood out like a sore thumb. Fortunately, NSF was joined by NASA Administrator Jared Isaacman on Friday's episode of The Flame Trench. He explained that Artemis III is actually more about testing Blue Moon's life support systems and cabin than testing Starship itself.
If you said, well, what if the Blue lander wasn't available, would you still do the mission, rendezvous docking and controllability check of the integrated stack? No, because you're not getting enough out of it to take on that risk. But with Blue there, and being able to test out a lot of the subsystems that are important, which frankly Blue does have to prove. I mean, SpaceX, we've gotten a lot of proof points over the years on their ability to manage ECLSS and avionics and rendezvous and docking. So a lot of those systems they know how to do, and we've been helping them on for as they adapt it to the HLS environment. So that's, I would say, less important in that environment. Rendezvous and docking, a multi-launch campaign, still very useful. Again, launching SLS and getting in a rhythm, very useful, but you're probably getting more in terms of your test data out of the Blue test lander than you would on SpaceX. But then you're gonna follow it up with 2 uncrewed end-to-end demonstrations of both vehicles. I think you combine that with the Artemis III objectives. Now you're starting to feel really good about Artemis IV.
This clarifies why SpaceX is not carrying a fully outfitted Starship human landing system for this mission, even though frankly, it would be awesome if they were to do so. Jared also pointed out on X that it's still valuable for Orion to dock with Starship and test the maneuverability of the combined Orion and Starship stack. Remember, it's a small spacecraft docked to a big ship. During the Artemis conference, Jessica Jensen stated that SpaceX is building the first flight fidelity HLS cabin at Starbase, and that it's already structurally completed. Hardware outfitting is next. This is quite interesting because we had already heard about this from SpaceX quite a while ago. On October 30th, 2025, SpaceX issued an update on its website stating that the company had started fabricating a flight article Starship HLS cabin. The update stated that this cabin would enable engineers to demonstrate high design maturity of the HLS systems, enable integrated system-level hardware testing, and provide highly realistic training experience for future lunar explorers. At the time, we were wondering where this cabin may be built, because there's only one area of the Star Factory that's tall enough to allow nose cones to be lifted and transported with plenty of room to move. That's the area we call the nose cone hall. There, the Star Factory ceiling is higher, and it also happens to be the side where the windows are facing Highway 4. Until recently, the only hint at a potential nose cone from this hall being for HLS was that one of them, at the time theorized to be for Ship 44, had seemingly been taken out of view and disappeared without a trace. Well, just this week, we spotted another anomaly in the nose cone hall. Normally, nose cones are built at the far right end of the facility from our perspective, and move to the left closer to the bays as they progress in construction. For example, here we can see this nose cone tip being worked on, likely to install the lifting points that will be used later in the construction process. It would not be surprising if this nose cone section will then make friends with the other half nose cone that we could see during the SpaceX IPO event on Friday. As we look to the left of that nose cone tip, there are two bare nose cones. One of them has no header tanks, the other one does. This is not surprising, as the one with header tanks is further down the production line, and there are dedicated header tank installation rigs for this purpose. Further left is another bare nose cone with header tanks. This is next to the new heat shield tile installation jig, where there also happens to be another nose cone. It's now receiving its own tiles. Presumably, this nose cone could be next in line after Ship 42's, which is sitting further to the left and is already stacked on its payload bay, as discussed earlier in the episode. Once again, we call that the further to the left, the further into production those nose cones are. However, there are two nose cones that are bare and lack tiles and flaps all the way to the left of Ship 42's nose cone. We're already getting familiar with one of them since it's been there for a little while. It's the nose cone we saw last month that had some weird equipment installed on its tip. In the past week or so, we've also seen that teams have installed a hatch on its side, very similar to the ones we see to enter the ship or booster tanks once they're stacked, for example. We've also seen a similar type of hole on the B-18.1 test tank. In that case, the holes cut into that test tank were used to fit pushers through them and test the new booster transfer tube design at Massey's. Given that this nose cone features header tanks, it would not be surprising if a similar kind of testing may be performed on it in the future. It might not be related to HLS, but we'll definitely keep looking for more weird things with that nose cone. That being said, the other bare nose cone next to it has no header tanks, no markings, no anything, and yet it's all the way down at the end of the production line inside the nose cone hall. So could this be the structure that Jessica was referring to? Are we finally seeing the HLS hardware that we've all been waiting for? There's only one way to find out. On top of all of the launches needed for the Artemis program and Starlink satellite deployment, SpaceX will need to ramp up its launch cadence quite quickly to also support its ambitious AI satellite constellation. While the intention is to start deploying this constellation as soon as late next year, Shotwell explained to CNBC that some of the hardware will be flying earlier than that on Starlink satellites in order to accelerate development. During Elon's talk published on Monday, SpaceX showed this bar chart of the company's planned upmass in metric tons per year. Assuming that the 2028 bar implies launching about a third of 500,000 tons, this would turn out to be just over 1,500 Starship launches in 2028, assuming 100 tons per launch. If we assume that version 4 is up and running by then, however, that would still mean over 800 launches that year, considering the quoted 200 tons per launch. That's a lot of launches, and yet it's a tiny bar compared to 2029, 2030, and so on. This is an ambitious ramp up in cadence like nothing we've ever seen before. Ever. In the entire history of SpaceX, the company's maximum increase in cadence year on year has been twofold, which is still impressive and something that's been possible to achieve thanks to Falcon 9 and its partial reusability. To put this in perspective, if SpaceX replicated that increase with Starship and launched twice as much this year than the previous year, and future years followed the same way, the company wouldn't reach 800 launches per year until 2032 or 2033. SpaceX will need a lot of infrastructure in order to support this, so it's no surprise we're seeing them quickly hitting milestones at Space Launch Complex 37. This week, our own Julia Bergeron spotted the massive LR-13000 crane stacking the first module of the first launch tower at this complex. SpaceX's Vice President of Launch, Kiko Donchev, confirmed on X that this first launch pad at Slick 37 will be known as Slick 37A. Hopefully, in a few years' time, we don't end up finding out from Dan Hewitt that it's actually Slick 37-2 or something silly like that. This is a major milestone for the pad, but it also means a lot of work remains, as there's no sign of a launch mount or even a flame trench yet. There's no tank farm as well, and all the ground infrastructure is still in its infancy. If the timelines for Pad 2 or 39A are anything to go by, it may not be until the end of next year at minimum that we might see Slick 37A operational, and there's still the other pad, 37B, that needs to be completed as well. SpaceX is also planning its own propellant production infrastructure for each pad, with plans for an air separation unit, a natural gas purification plant, and a methane liquefier at each location. The only place where any major progress has been made towards this is Starbase, where an air separation unit has been under construction for some time now, and paperwork is being worked on for SpaceX to pipe in its own natural gas with a pipeline. In order to meet this unprecedented ramping cadence, SpaceX will also need lots of vehicles. The company has 1 million square feet to play with at the Starbase Star Factory, and 2 gigabays are being built as well for vehicle stacking, one at Starbase and another in Florida. Florida's Gigabay is the furthest ahead. This week we saw the removal of the 2 remaining tower cranes that were being used to build the bay, and we've also seen great progress on the installation of the roof over the building as well. At Starbase, considering it's behind, teams have only just started construction on the topmost level, with the first few columns being installed. Completing the building is one thing, outfitting them is another beast. One key to know whether they can support a ramp up in cadence like the one planned will be if we see SpaceX start to mass produce the work stands and tooling necessary for these gigabays. If they start on that work soon, they could be on the right path. You'd be forgiven for saying that there's a high likelihood this planned increase in launch cadence won't end up happening, but it's also clear that if SpaceX is able to achieve even a tenth of what they showed us in this graph, it would be a really busy future for Starship in the coming years. I've been Caton for NSF, thanks for watching, and goodbye.